Okay, so I have here 5 equations that try to combine all the concepts that we've looked at with regards to exponential equations. So here we are trying to see if we can recognize the patterns, especially with regards to the rules and the laws of exponential functions. So let's start and go through one by one. Okay, so this is our first equation. What we do here is the first thing when you look at this, you have to be able to recognize the patterns. And we said that when we are dealing with exponents, the most important factor is to understand the base that you're dealing with. So I can already see here that the primary base that I should be working in is 3. Okay, so I look at where I can simplify and create this base. So I can see I can create this base here, create that base here, because I'm looking at the ones that have got the exponent. So it's x here, x here. I'm not worried about this because there's no exponent here. So here I begin to simplify. I know that I'm trying to create this base of 3. Okay, so I go here and I do this. So I repeat everything else, and I'm trying to create this. So this I can also now adjust and reverse these rows here. Okay, so I can now do it like this. Now I go on and say, for example, let 3x become p. Okay, so here I can say p squared minus 5. Here this is p, so I can put p plus 6 equal to 0. Remember our quadratic equations, we already know the product is 6 and the sum is minus 5. So it can only be these two. Okay, is equal to 0. So now we can say p is equal to 2 and p is equal to 3. So what can we do with this? We already said that we've already converted this. Okay, so now we can replace p here, say is equal to 2, and then we can also say 3x is equal to 3, right? So this one you can't directly solve. You need to apply log, and then this one here, okay, we are going to apply the same, but this will be power 1. Okay, so this immediately we can see that x is going to give us 1. Okay, but for this one we need to apply the same thing on both sides, which is log. So it doesn't matter the base as long as you apply log. Okay, okay, so let's apply log. This will become 3x is equal to log 2. Now remember, here I'm looking for this law that brings this one down, if you remember. So x is going to be log 3, which is equal to log 2. So now x, the other value of x will be log 2 over log 3. The next equation, again, we check the base. What base can we use? We use base 5. So 5 to x minus 5x. This comes this side, then it's minus 20 is equal to 0. Okay, then here we are trying to have this. Right, then this, now we can put a variable here like p squared minus p, because we're saying 5x is equal to p. Okay, minus 20, similar to the previous example. Then if we expanded this, or if we factorized here, we'll get p minus 5, okay, and p plus 4 is equal to 0. So we're saying p is equal to 5 and p is equal to -4, right? So those are the values. Now we are saying that p is equal to 5x. So we said p is equal to 5x, 5 power x. So we can get these two values. Get 5 is equal to 5x. We can even apply logs. So log 5 is equal to log 5x, like that. Then this comes down there. So it becomes x log 5 is equal to log 5. So x is equal to, so these can create ones here. Then we have x is equal to 1. The other one, where we have -4 is equal to 5x. Now look, this doesn't have a negative here, but this one has got a negative. So already we can say that this cannot exist. If we were to apply logs, we'll be trying to find log of a negative number. So this we can't. So this is not possible. The only value we have is this one. Okay, so this is another equation. Again, here, when we look at this, we are trying to see that, what would be the most appropriate base that we can use here. And already we can see that we have 5 here, and we will hope to have 5 here as well. So this is going to be 5, 3x minus 2 equal to, so we try to work with this guy here. So that'll be 5 power 3, right? And then this is 125, so this is 2x. Now remember, we had one of the laws of the exponents was that if this is brackets like this and then you have that, these multiply. Okay, so the same base, these are going to multiply. So we have 5 power 6x. Now here, there's something crucial that we need to see. You can see that this is the same base. So if you're careful, you can say that this whole expression here is equal to that expression here, because we're powering the same base. But the official way of doing this is you apply logs to both sides. Okay, so you have 3x minus 2 equal to log 5, and then you have 6x. Now we had that law that brought this down, okay, like that. So we're going to have 3x minus 2, like that. Then we have log 5. So this is in this is log 10, log base 10 here. Okay. Then here we're going to have 6x, and then we have log 5. So we can divide by log 5 here and by log 5 there. If you want to show all your working, you can do that. So we're going to have 3x minus 2 is equal to 6x, right? So this, I can bring it this side, the other one, or I can, at this point, this should be easy. So we can do it whichever way we want. So this is 3x is equal to minus 2. Therefore, x is equal to minus 2 over 3, like that. Okay, so what can we do with this? We first of all are going to check if these can be set into different bases, into same bases. So these we can, so we're going to separate them. So this is going to be x minus 1 is equal to 2x. And then we apply same log on both sides. Okay, so this is log base 10. Okay, like that. Then remember that law, this one comes down. So this is x minus 1. Okay, then we're going to have log 5 here. Okay, we're going to have log 5. And then here we're going to have x log 2, like that. right? What other patterns can we see here? Okay, we can't expand this any differently. Okay, we can, but the easiest way of doing it is to expand this. So I'm going to say x log 5, okay, x log 5 minus log 5 equal to x log 2. Okay, I'm going to bring like terms on the same side, so it will be x log 5 minus x log 2 equal to log 2, log 5, okay, log 5, this one, sorry, this has gone the other side. And then I can factorize here, log 5 minus log 2 equal to log 5, like that. So at the end of the day, x becomes log 5 divided by log 5 minus log 2. Okay, so here, this is one way of doing it. There's you can do it differently. So the other way maybe that you can do this is, remember, this is when it's like this, it means that we are doing what? We are going to divide these two. So you can actually do 5 power x over 5. Then you expand it to that side, you bring the other one, the other side, apply the logs, it will still come back to this one here. So the same equation, we said that we can have another way of doing it. So remember, we had the quotient rule. So the quotient rule came from, we said that if we have something like this, m minus n, this would be the same as am over an, something like that. So this is, we can recognize that pattern here and say that this is 5x over 5, 1. Then this will be minus 2x equal to 0. So now this is the same equation. I'm just trying to show us that we can actually do it many ways. So this now comes this side. Now what is critical here is to remember that this becomes positive. Okay, now I can take this the other side. It's division here, becomes multiplication there. So this is 5 power x is equal to 5 times 2 power x. I can take this and bring it this side. So I have 5x over 2 power x equal to 5, like that. At this point now, I can apply my logs because there's nothing else I can do. So I'll apply my log. Okay, so 5x over 2x equal to 5 equal to log 5, like that. Okay, now we continue. This is the same as, we said that this is subtraction. It's the same as subtraction. So I can do log 5x minus log 2x equal to log 5. Okay, then we say that this can come outside here and create something like 5. Then this one here can come here and create something like 2. Okay, and then here we have log 5. I can factor x out, and then I have log 5 here minus log 2, which will give me log 5, right? So now I can divide with this both sides to give me x is equal to log 5 over log 5 minus log 2. You remember that this is the same solution that we just had, but we solved with a different method. So the key to understand is that it's just about recognition of patterns. Those laws or rules that we went through, can you see them when they give you an equation? That is what is crucial. Here's another one. What is our thinking pattern here? Remember the first question we ask ourselves is, can I work through all the terms in the same base? Okay, the ones that have got exponents, okay, like a variable in exponent, can I put them in the same base? So already I can see that I can do this. Okay, so I will do this like this. Then here I know that I have 2, then I can power 2 like that, then is equal to 32. Now all this is multiplication, so it makes it easier for me. So what I'll do is I'll put these two together. Okay, I'll put these two together. We said that if we're multiplying same base, we're actually adding their exponents. So this is 2x minus 1 plus 2x plus 1, and then I get 32. Already I can see that this is also, I can also expand this into 2 power 5, right? So I'm already seeing where I'm going. Okay, so here I can say 2, this I can repeat it, but this I can expand, so I'll get 4x plus 2. Carefully, I have to be very careful, because if I lose one term here, then I'm gone. Okay, so this is going to be 5x, and then this is going to be minus 1. So this is 5x plus 1, right? And then it's equal to 2 power 5. And I say if these are the same base, you can actually just equate this and that. But the official way of doing it is we apply the same log. Okay. 5x plus 1 is equal to log like that. Then you have 5, right? Then this comes down. Okay. Then we have log 2 here is equal to 5 here, and then log 2. Okay, so I can get rid of these 2, giving me 5x is equal 5x plus 1 is equal to 5. So my 5 goes the other side. 5x is equal to 4, and then x is equal to 4 over 5, like that. So you see that this is just about recognition of patterns.